Hi math students, this video is to help you with the Algebra 1B Unit 6 focus notes. So you should know the directions by now, but make sure you have this paper printed out so that you can follow along and fill it in with me as we go. And then when you're done, you're going to take a picture to submit it for your assignment. Okay, so our initial question this time, what does the correlation coefficient of a function tell us about the model? So this is what we're just thinking about. Remember, we're not going to answer it right now. We're just thinking about this question. What does the correlation coefficient of a function tell us about the model? So the initial question, what makes a strong correlation coefficient? So a little bit more specific of a question. Again, we're not going to answer it right now, but we're going to list some sources. Where could we find information about correlation coefficient? So of course, you can always search the web for these things. You can also go to your lesson. So if I go here, here's the lesson on correlation coefficient. This was workbook 28.1. So I'm going to write that as one of my sources because this lesson on correlation coefficients is going to help us. So workbook 28.1. That's going to be my main source. And if I need any other sources, I can always list them there as well. So our key academic vocabulary, we have correlation and correlation coefficient. So we can go to the lesson here, and remember, you could always find these words. So here's correlation coefficient. If you click on it, it tells you a lovely definition. A measure of strength of a linear relationship between two variables in a data set. The measure is between -1 and 1, with the values near the extremes being the strongest, and with the values near 0 being weakest. Okay, so that's a lot of words for correlation coefficient, but notice the first part, it says a measure of strength between two variables. So that's what I want us to write right now, a measure of strength between two variables. So a measure of strength between two variables. The other thing, remember, you can pause this video anytime if you need more time to write. The other thing it said is it's always between -1 and 1. And it said the stronger ones are the extremes. So the closer it is to -1 or the closer it is to 1, those are the stronger correlations. And the ones closer to 0, since 0 is in between here, those would be the weaker correlations. So we didn't find a definition for the word correlation. So if you can't find it actually in the lesson, this is a time when you can just search for it. Correlation. So correlation says a mutual relationship or connection between two or more things. So I'm going to write a connection between two or more things. So think about correlation like this. If we were comparing the number of hours somebody studied for a test and their grade on that test, there's probably a strong correlation between that. Somebody who studied for a lot of hours would have a higher grade. Somebody who studied for no hours would have a lower grade. So that's what correlation means, connection between two things. Sometimes you might want to compare something like the number of hours somebody studied on a test and their favorite ice cream flavor. Well, those two things don't actually have anything in common, so they probably shouldn't have a very strong correlation coefficient. So we'll see some examples here in a minute. Okay, so applying what you know. So this question is just asking you, is 0.3 closer to 1 than -0.8 is to -1? Okay. So which one is closer? Is -0.3 closer to 1 or is -0.8 closer to -1? So take a minute and think about that. I'm going to show you an example with different numbers because I don't want to give you the actual answer here, but I'll talk about something else. So if I just use my examples right here, is -0.2 closer to 1 then negative 9.93 is to negative 1. So if I think about a number line here for a minute, here's 0, here's 1, here's negative 1. So 0.2, let's say I had these separated into tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 0.2 would be right here. 1, 2, 3, 4, 5, 6, 7, 8. I gotta fit one more in. Negative 9.3 would be like right here. So negative or positive 0.2 is not as close to 1 as negative 0.93 is to negative 1. So if my question said, is 0.2 closer to 1 than negative 0.93 is to negative 1, I would say no, it's not closer. So take a minute and answer the question that you have printed on your paper. Don't answer about my numbers. You answer about your numbers. And here's our second example. I'm also going to draw a number line for this so you can have a visual. So I have 0 in the middle, 1 over here, and negative 1 over here. There we go. Okay, so negative 0.84. So I would go back 8/10 and a little bit more. So that's negative 0.84. And then we had 0.72, so I would go over 7/10. 1, 2, 3, 4, 5, 6, 7, and a little bit more for 0.72. So is negative 0.84 closer to negative 1 than 0.72 is to 1? So take a minute and look. Which one's closer? Is this one closer than this one? And answer either yes or no here. So now we're going to take those same problems that we just did, and we're actually going to answer a question about them now. So the correlation coefficient of Bobby's function is 0.3. Should Bobby rely on this information to be accurate? So back in the lesson, it talks about what makes a strong correlation coefficient. So the closer you are to 1 or negative 1, the better your correlation is. So 0.3, if I looked at it on a number line, it would be like right here. 0.3 is not very close to 1. It's much closer to 0. So should Bobby rely on his information to be accurate? I would say no. 0.3 is not very close to 1, so it's not a strong correlation coefficient. Over here, the correlation coefficient of Jose's function is negative 0.84. Should he rely on this information to be accurate? So remember, we drew this number line here. Negative 0.84. That is pretty darn close to negative 1. And remember, the closer you are to 1 or negative 1, it doesn't matter positive or negative. It's just the closer you are to these two numbers, the stronger your correlation is. You can kind of think of this as like getting an 84% on a test. So an 84.84, I would say that information would be accurate. So I would give this one a yes. Okay, so now a couple more here. Give an example of a strong negative correlation coefficient. So now you get to make up your own. Make sure it's negative, like this one, negative 0.84, but a strong one. So something that's close to negative 1. And over here, you're going to give an example of a weak positive correlation coefficient. So weak, that would mean it's not close to 1. It's something that's much closer to 0, but make sure it's positive. Okay, so take a minute and answer each one of those questions. Pause the video if you need to. And then at the end, this is where we summarize what we learned. What does the correlation coefficient of a function tell us about the model? So we just talked about a lot of those. What does it mean if it's close to 1 or if it's close to negative 1? What if it's not close to 1 or negative 1? So you're going to kind of summarize this here. What I would probably say is if the correlation coefficient is close to 1 or negative 1, the model has a strong correlation. That's how I would summarize it. If you have a number that's close to 1 or -1, the model has a strong correlation. If not, it has a weak correlation. How can this knowledge be applied in solving future problems involving correlation? So now that you know about correlation, you'll be able to test the accuracy of models. By looking at that correlation coefficient, you'll know whether you should be able to rely on that information. So here I would say something about, I will be able to tell if a model is reliable. If it has a strong correlation coefficient, you'll know, yes, I can trust that information, that's reliable. If it doesn't, then you can't trust that model. So you don't have to write these exact words. You can summarize it in your own words. And then remember, you're going to do a little Flipgrid video or a written explanation here on this next assignment. So you're going to use this part for that. So go ahead and take a picture of these pages so you can submit them for your assignment.